It is 23rd of September 2025. I'm going to talk about deep learning. First, we have element-wise operation, broadcasting operation, and map multiple operation. Element-wise operation is for every tensor and every each of the uh, vector dimension, we do element-wisely. For each of the element, we do multiplication. For broadcasting, this is kind of concept that is a virtual concept because when you think of the vector uh, X matrix X, which is 32 dimension and 10 dimension, and matrix Y, which is 10 dimension, then in computer, what we should do is in broadcasting X equals to 32 and 10, and let's say Y equals to 10 dimension, then we should add this one, and after that, we should change it to Y equals to 1 comma 10, and we will multiply all. Basically, what we are doing is, and it becomes Y equals to 32 comma 10. So it has 10 dimensional, it is 10 dimensional vector, and we will stack it 32 times and do it. And even for linear transformation, like the multiplication and addition, even we do it, it is still same as just do one linear transformation. That is why do nonlinear transformation. If we do nonlinear transformation, then from output minus infinity to infinity, the real range number can be from output of 1 and minus 1 or 0 and minus 1. That is important thing. This is, yeah, in each of the layer, there's activation function. And if you think of this picture, this is a really simple and nice picture. If you think about the loss function, if y equals to 0, then loss becomes like this. And if y equals to 1, then loss becomes like, this is the loss function here. L equals to minus y log y hat minus 1 minus y log 1 minus y hat. If you think of it, why we should define it like that. If y equals to 0, then log 1 minus I y hat, which means if y hat is 0, then it will be close to 0. But if y hat is 1, then it will be minus log y1. Y hat is 1, then it will be super increasing. That is why it defined it. Think of the minus log y function. Minus log y function is like this one. And how to train minimize loss function, how to minimize gradient descent methods come out. So here I made some mistake. Let's think about it again. X, the trainable parameter, adjustable parameter is W and H and Y hat. So we are, H will be function of W, G of W, because W by W is changing, H is changing, and Y hat is function of H, because Y hat is by H is changing, it will be changed, and H is function of W, because when H is changing, W is changing. So basically, when the loss come out by calculating this process, we just do a partial derivative. Then Y hat minus Y and Xi will become out for each of the process. Then we can calculate the new weight parameter by from old parameter minus recurrent learning rate and gradient. So basically, we are uh, subtracting the gradient. And this is the picture of, yeah, XOR. Why XOR is impossible? But for these two, we can simply splitting by linear classifier, but this case this is different. But how about if we introduce two perceptron, H1 and H2, then let's say H1's bias and weight is following. 20x1 plus 20x2 minus 10, 20 minus 10x1 minus 10x2 plus 30, and each of it has sigmoid function, and there will be y. Then if we put input is 0 and 0, then in this case 0 come out, and input is 1, 1, in this case 0 come out, input is 1, 1, then 1 come out, and input is 1, 1, 1. Wait a minute. It should be 0, 1. Yeah, input is 0 and 1, then 1 come out. Input is 1 and 0, then 1 come out. X1 is 1 and X2 is 0. In this case, 1 come out. So XOR is satisfied. And this is very important picture. There is 2 node and 4 node is next one. Then I will show you later. Basically, input is d-dimensional. Then W matrix will be k comma d dimensional, and bias it will be k dimensional. Then bias, in this case, bias is 4 dimensional. Each of the 4 dimensional is going to each of the next node. That's how it works. And regression case we use squared loss, and classification case we use cross entropy because each of the y hat, the predicted value is just become h1, and classification case this is become whole the exponential of hi, the sum over each of the thing. And forward pass, yeah, this is classification case. There will be weight matrix and multiplication. We can also represent it by the dot product, and we can also compute from error. We can backpropagate the error y hat and h and w. Okay. From now on, we are going to see the more mathematics. Yeah, if you see here, this is the parameter. Each of parameter number will be k multiplied by d plus k. This is weight matrix. First method we can change the weight is change each of the element changing and check the weight, but we just use gradient descent. And yeah, this is the linear functions definition. Okay. Even we do ReLU, how we do ReLU is, think about it. From there's input d-dimensional, d multiplied by 1, and there is k multiplied by d and d. If we do that, then that is basically matrix multiplication with the w and x plus b. We just do ReLU. Then result is same, just k-dimensional. That is why it is k-dimensional. And the k-dimensional things will be split into the next node. That is how it works basically. Yeah, thank you very much.